This Explain Everything is on the 4 types of acid-base disturbances, remembering that the 2 main types are respiratory or metabolic, and that they're either going to be acidosis or alkalosis. Let's start with respiratory acidosis. The fact that it is respiratory indicates that the cause was due to a respiratory problem. And what we're going to look at here is that there has been an increase in CO2, and that would have resulted from hypoventilation, okay, which is going to then shift the equilibrium to the right, and as a result, increase hydrogen ion concentration. Remembering that an increase in hydrogen decreases the pH, and that is why this is acidosis. So the key thing here is that the cause was a change in the CO2, and the result was a change in the pH. Next, we look at respiratory alkalosis. Again, because it is respiratory, we know that the cause was a change in the CO2. In this case, it was a decrease in CO2, and that would have been because of hyperventilating. And as a result, the equilibrium would have shifted to the left and would have decreased hydrogen ions, as a result, increasing pH, and this would have been alkalosis. Again, respiratory because the cause was a change in the CO2. The effect was to change the pH. Next, there's metabolic acidosis. In this case, the cause is a direct change in the hydrogen ion concentration, and because this is acidosis, we will have increased the hydrogen ions, which would shift the equilibrium to the left and increase CO2 levels. Looking at this compared to the respiratory acidosis, both CO2 and hydrogen ions increase, and what we have to appreciate here is that in the metabolic disturbances, the cause is a change in the hydrogen ions, and as a result, the CO2 levels change. In order to distinguish these through blood gas analysis, we are going to have to take into consideration what is happening to the bicarbonates. The final disturbance is metabolic alkalosis. Again, because it is metabolic, we know that there must have been a direct change in the hydrogen ions. Because this is alkalosis, we know that the hydrogen ions decrease. That would have increased the pH, and that would have shifted the equilibrium to the left, and therefore the CO2 levels would have decreased. Again, metabolic, the cause was a direct change in the hydrogens, and as a result, the CO2 levels would have changed. To detect the difference between metabolic and respiratory, again, we would have had to look at what happens to the bicarbonate levels. Now let's look at the homeostatic responses to these disturbances. There's going to be respiratory compensation and renal compensation. Remembering that respiratory compensation is only going to be for metabolic disturbances. So first, let's look at metabolic acidosis. Going back, we'll just review what the cause of this disturbance was in the first place, was an increase in the hydrogen ion concentration. Okay, remembering metabolic disturbances, the cause is it directly with those hydrogen ions. That would have shifted the equilibrium to the left and increased CO2 levels. Okay, as a result, the body is going to respond by increasing ventilation. Now, this is just the respiratory homeostatic response. You increase CO2, you increase ventilation. What this is then going to do is decrease CO2 levels, okay, shifting the equilibrium to the left and therefore decreasing hydrogen ions, which is going to increase the pH and compensate for the original decrease in pH that was caused by the metabolic disturbance. Now let's look at what the respiratory response or the respiratory compensation would be for metabolic alkalosis. Remembering again, the cause was a direct alteration of the hydrogen ion concentration. In this case, it would have been a decrease in hydrogen ion concentration, which would have increased the pH. And as a result, the equilibrium would have shifted to the right, and we would have decreased CO2 levels. The body's natural homeostatic response to a decrease in carbon dioxide is going to be to increase our ventilation, which then increases our CO2 levels, which shifts the equilibrium to the right, and as a result, increases hydrogen ions and decreases pH. Again, appropriate homeostatic response or compensation for the original disturbance, which was an increase in pH. Let's now look at renal compensation for both types of disturbances, respiratory and metabolic, recalling that respiratory compensation was only for metabolic disturbances. Also note that the respiratory compensation is relatively quick, the renal compensation is slower. So before we go any further, let's just review the movement of substances in the renal tubules and recall that reabsorption is the movement back into the blood, so levels will increase in the blood, whereas secretion would be removing substances from the blood and therefore decreasing the levels in the blood. Let's first look at acidosis, and remembering that this could either be renal or respiratory, it does not matter. So in cases of acidosis, what's happened is hydrogen levels have increased, and what we want to now do is to get rid of those hydrogen ions, so we want to secrete them. The other way of looking at this is we could also reabsorb bicarbonate, which would then help buffer that increase in hydrogen ions. Now let's look at what's going to happen. Okay, renal compensation for alkalosis, and again, this could be respiratory or metabolic. So what's happened in alkalosis is that the concentration of hydrogen ions have decreased. So what we now want to do is to reabsorb the hydrogen ions, or in another way of looking at it, we could secrete the bicarbonate, which then would also have the effect of increasing hydrogen ions. Okay, and in the next slide, I'll just show you a summary of all of this. So in summary, if you look at this little chart, all you have to really remember is that in acidosis, you want to get rid of those hydrogen ions, so therefore you are going to be secreting them. And then remember, everything else is just opposite. So if that's secretion, this is going to be reabsorption, reabsorption, secretion. Okay? Quick and easy way to remember what is happening to those hydrogens and bicarbonate under conditions of either respiratory or metabolic acidosis and alkalosis. Now let's look at the interrelationship between hydrogen and potassium in the secretion and reabsorption at the kidney tubules. Okay, these are specific different types of cells in the tubule. There's type A and type B. Type A has to do with acidosis. So let's just look at this. Okay, this is acidosis. These are type A intercalated cells. And what they are doing, as we've previously noted, that in acidosis we will be secreting hydrogen ions to try to get rid of them due to the increase in hydrogen ion concentration. Okay, so we're getting rid of them. Okay, and I'm not going into all the details. You have it in your notes. It's due to the arrangement of all these transport proteins in these cells. What happens is that hydrogen ions are being secreted. Potassium ions are being reabsorbed. This increases the potassium levels in the blood and is going to lead to hyperkalemia. Okay, and as we discussed, hyperkalemia can lead to a variety of problems, including cardiac arrhythmias. Now let's take a look at what is happening again, the relationship between hydrogen and potassium in alkalosis. So what has happened is the hydrogen ion concentrations have decreased in the blood, and as a result, the tubule, we would have been reabsorbing those hydrogen ions, and the interrelationship again, not going into the details, but as hydrogen ions are being reabsorbed, potassium ions are being secreted. This would have the effect to decrease potassium ions and now causing hypokalemia in the blood. So remembering pH can disturb potassium levels. This hypokalemia could lead to a failure of the skeletal muscles and could cause problems with respiratory and heart muscles. So to summarize this again, remembering that in acidosis, hydrogen ions are going to be secreted. In alkalosis, they are going to be reabsorbed. Remembering potassium is always the opposite, so we are going to have reabsorption and secretion. And then just look that if reabsorption of potassium occurs, we are going to increase potassium levels, and this is going to result in hyperkalemia, whereas the secretion of the potassium ions will result in hypokalemia. So, remembering acidosis is hyper, alkalosis is hypo. What I haven't talked about yet is what's happening to those bicarbonate levels. So let's just quickly review that. In acidosis, what was happening in response to a respiratory problem, we were say, increasing CO2 levels, which would have increased hydrogen ions and increased bicarbonate levels. Okay, so this would have been respiratory acidosis. Okay, so in respiratory acidosis, you are going to see an increase in bicarbonate levels. Okay, note in your notes, in the chart, it says that bicarbonate levels are within normal limits. Theoretically, they do, well, in reality, they do increase. However, the concentration just may not show up clinically because it is so more concentrated in the plasma compared to hydrogens, so the relative change may go unnoticed. So theoretically, or in actuality, they do increase, but clinically, they may show up within normal limits. Okay? Let's note here that the hydrogen ions increase, which means that the pH decreased. And looking at this when you're doing blood gas analysis, here we have an increase in CO2, a decrease in pH. Therefore, they are opposite, which indicates that this is a respiratory disturbance. Now looking at respiratory alkalosis, again, the cause is going to be a decrease in the CO2, which shifts equilibrium, which then decreases the hydrogen ions and decreases the bicarbonate. Again, if you look at the chart for respiratory alkalosis, you're going to see that the bicarbonate levels are showing up within normal limits. That is clinically, however, they really would have changed, you're just not detecting it. So looking at this, because we have a decrease in the hydrogen ion concentrations, we are increasing pH. In this case, the arrows for CO2 and pH are again opposite, which indicates that this is a respiratory disturbance, and because it's an increase in pH, this would have been respiratory alkalosis. Okay, now let's look at the metabolic disturbances. First of all, let's look at metabolic acidosis, in which case the hydrogen ions have increased, so the pH decreased, in which case it shifted the equilibrium, so CO2 levels increased. If the equilibrium shifted to the left, the bicarbonate levels would have decreased. Okay, so this is a metabolic disturbance because we disturbed the hydrogen ion concentration directly, and because we had a decrease in pH, this would have been metabolic acidosis. Okay, looking at the chart in your notes, you will notice that for metabolic acidosis, the pH has gone down, the bicarbonate levels have gone down. However, it says that the CO2 levels are within normal limits. Okay, this is assuming that there has been respiratory compensation. Therefore, your breathing rate has changed and returned those CO2 levels back to normal in an attempt to alter and compensate for the pH change. Okay, so again, kind of theoretically, the CO2 levels would have changed if you could have caught it right as it was happening. However, clinically, you would have been measuring these levels later, and the CO2 levels would have returned if there was appropriate respiratory compensation. So the final disturbance is going to be metabolic in nature, which means we are directly affecting the hydrogen ions. We are going to decrease them. So this is an increase in pH, which of course would have been alkalosis, and because it was a disturbance of the hydrogen ions directly, it would have been metabolic alkalosis. If you decrease those hydrogen ions, it's going to shift the equilibrium to the right, which would have decreased the CO2 levels and increased the bicarbonate levels. Again, if you look at the chart, you will see that those carbon dioxide levels are within normal limits. This is assuming there has been appropriate respiratory compensation.